And we're back with another panel. This is a good one for everybody that wants to talk about the future of AI, where we're headed. We're going to talk about the near future. I hope we can talk about the far future. That's always fun to talk about. And like I keep saying, when you hear it here, it's the future now, and it's going to be reality in 1 to 2 years. So that's where we're going to start off. I want to start off with, you know, now everybody is talking about data mesh and stuff because these are the hype words now, but I want to hear the hype words that are going to be relevant in 1 to 2 years. And you guys are well poised to give us good insight into that. Please introduce yourselves, and then we're going to go around and touch on some of these words.
So I'm Seth Dobrin. I'm the Global Chief AI Officer for IBM. I've been at IBM for about 5 years. Before that, I worked at a couple other Fortune 500 companies using data and AI to transform them. And we talked about earlier, my background's actually in human genetics. So really building out these tools, using these tools 25, 30 years ago that we use for data science today.
Awesome.
Wonderful. So my name is Anurag Sahay, and I am the Global Practice Lead of AI at Nagarro. We are a software services company, and we solve a lot of AI data science problems for our customers. I, by training, am a data scientist, but before there was data science, I was doing more simulation, modeling, and performance optimization, so I have a bit of a maths background. I was with IBM when I started, so there you go, we have something common. I was with Nokia and Microsoft in Redmond, and then got into these topics of data science, worked with an e-commerce company to set up their data science setup, and then since then I've been building teams around data science and deliver data science AI projects for organizations.
Awesome. What kind of simulations were you doing?
So these were, a lot of them were physical or mathematical in nature. Agent-based modeling was a very important idea that we used. And those days we didn't have frameworks that would make it simple.
Yeah.
So we used many other programmatic ways to try and do things.
Yeah.
Complexity or complex systems are, they have been around for a while, and a lot of mathematical modeling is now getting rooted in those kinds of theories. So that was the concept.
We should I want to circle back on both of these things because that's going to be the future, maybe more than 5 years into the future, but we're already starting to see things. Computational biology is a thing, right? I mean, every field of science is becoming a computational field. And in simulation, AI is playing an important role now as well. So we'll circle back to them, but let's look at the stuff that we're talking about now. Like I said, data mesh is something that everybody's talking about, but that's because it's actually happening now. What are the trends and changes and hype words that are happening now that we're going to see be put in practice in the next 1 to 2 years, in your opinion? What do you
like
think?
we were talking about yesterday, I think data mesh in my mind, and according to Gartner, is a static construct, meaning it's not live, it's not real time, you're not actively enforcing governance or policies, not actively updating metadata. The trend is now moving towards data fabric, which is a more uses active metadata, uses concepts like observability, similar to software development, where you're looking at how do you get SLAs around my data, how do I make it a product, same thing with your models, how do I have SLAs around my model, and all the metrics we think about, so they're a product that can actually support a software development DevOps pipeline. I don't like the word MLOps because it's not a good analogy. Software development, static and finite. AI and machine learning are anything but that. So I think the shift over the course of the next year is going to be towards data fabric. We're seeing a lot of customers implement that today. I think the other shift is, there's two other shifts. One is around AI governance. So really holistically looking at AI governance from the data throughout its life cycle, auditing it, documenting it, having good explainability across the whole pipeline, and then ESG, right? Environmental and social responsibility and social governance is incredibly important, and AI is going to be a big factor in that, as well as just the base data. There's a lot of data that goes into it, but I think those are the three trends I'm seeing that you're going to see a huge uptake for this year.
Okay. Well, what do you say? What are the next?
So a lot of those things that you touched, I would agree with that actually, and so my answer is not going to be that original, but just to complement that a little. We are seeing a trend around AI taking a bit of an avatar into engineering. Like, while there's a lot of energy that's going in building complex models and so on, AI is becoming an engineering problem at some level for organizations. And tools and topics and themes that can help make that a little easier for organizations is becoming the trend. So a lot of customers we work with are looking for, is there frameworks, is there platforms that can just simplify our AI. And we don't want to be talking too much about modeling. We're talking end-to-end AI engineering at that level. So that's one important thing in our mind. Right? The second is federation or federated ways of doing things, whether that's training in a federated way or pushing models. And you look at a Tesla today, right? I mean, it takes about 2 weeks to train a model on self-driving, but the updates, like, over a matter of few seconds, and it's trained on your context a little, and I don't know how much of that really happens today, but it's going to be happening soon in the future, right? So federated learning, federated management, federated governance are very important ideas that I think would play out in the company.
Yeah, and federated learning is especially important when there's data residency or data sovereignty laws.
True.
So that you can still get insights from these areas where you're not allowed to move data out of. You can then retrain, have that inform your whole bigger models.
Right. Right.
Is this driven by new technology that supports these kinds of changes, or are they sort of demands from the organizations?
It's both, right?
Yeah.
So there's definitely demands, and the regulation environment sets up the context and constraints for such a thing. But technology has to keep up and make that happen, right? So I think people have started thinking about those kinds of tools that would help the model to go to the data rather than the data to come to the model.
Yeah.
So there's a lot of simple tools. I mean, I can't think of a very clear set of things that we can use, but we can clearly see innovation happening in these areas.
Yeah, and back to your comment about data mesh, data fabric. Data fabric, that's one of the things it brings the ability to have federated learning. I think technologically we're to a point where you can do, you can have a model learn at the edge, bring the parameters back to the main model, retrain the main model, and then deploy it back out. Or you can just retrain, customize at the edge, and still maintain that performance and monitoring. The key before was, I really can't monitor at the edge, and I really can't, well, I can monitor at the edge, but I can't do anything about it because it's completely disconnected. So if you look, if you consider like mainframe, was kind of an edge.
Yeah.
Well, it's still, by the way, it still runs our economy. Almost all transactions around the world operate on some mainframe. And banks have needed to score fraud models on the mainframe for a long time. And so they would train them offline because it's very expensive to do these things on the mainframe, and then they'd move them back. It was very disconnected. It was kind of an iterative back and forth, very manual. Today we're to the point where you train a model on GPUs, on NVIDIA GPUs somewhere, and that model automatically gets updated and redeployed directly on the mainframe in live time and still scoring sub-second fraud models.
Right.
Yeah.
And I think there is an analogy here between the companies in the early days of sort of scaling over through the internet, and where they had the ability to make their own data centers and that kind of stuff, and other companies didn't have those abilities, and the cloud really democratized even a startup's ability to scale globally in very short amount of time. We're seeing the same sort of have and have-nots in AI and data governance, where now we're seeing tools that are sort of commodifying these best practices and really making them available to people that weren't able to do those types of things before.
Yeah,
True.
yeah, I agree. I think build platforms are commodity. Auto AI capabilities.
Low code,
no code, low code are commodity. I mean, there are each of the we have our in Watson Studio, which is our build platform. We have Auto AI. The key differentiator in that is the ability to do time series. None of the other Google's, Microsoft's H2O, they can't do time series. So they all have their different, Google's does image better than we do on it. They can do image. And so they each have their own advantage. I think build platforms, you should use the one that's right for you, or the one that you're using, and then look at how do I wrap governance around that, so that I understand what's going on, I can control my environment. That's really where companies should focus their efforts. And I'm also a huge believer, and I practiced this before I joined IBM, that your team should build things, capabilities, software capabilities, or enable platform capabilities that aren't available as commodity. As soon as they're commodity, you should buy whatever best of breed is at the time, and then focus your intellectual capital on things that are truly differentiating.
Yeah.
And there's a very interesting example in the history of how software has come about. I mean, when relational databases came about, a bunch of people were just trying to build relational databases themselves until Oracle really standardized it.
Right.
And that was the end of that, right? And
Yeah.
people start building. So I think a lot of that happening even today in a lot of these topics. People try and get into building it themselves. And there's a thing about let's not buy, let's build. But at some point, you're not going to be able to do that.
You're wasting money, right? Look at Hadoop 10 years ago, right? Everyone, not everyone. There are half a dozen companies my former
Right.
company included, that were managing their own Hadoop. As soon as Cloudera introduced managed Hadoop, all of these leading edge companies went on to Cloudera. Same thing with Cassandra and Databricks. Same thing with Kafka and Confluent. The companies that are if your company wants to be leading edge or behave like leading edge, don't keep building stuff that you can buy. Build what you can't buy, take advantage of the newest technologies. That's how these companies like Capital One, like my former company Monsanto, like Bank of America, that's how all these companies are constantly leading. They're not managing these platforms by themselves. They're building them, they're setting the groundwork, they're working with these startups. And they buy these products and move on to build something else differentiating with open source.
Well, that has to be a key takeaway here, that you should be building stuff that you can't buy off the shelf. A lot of the stuff you can buy off the shelf is, a well-established best practice stuff. There's no point in redoing that if it's established that that's best practice.
And it already does the security, it already does the scalability,
But see, this is also very natural that at this point of time, the environment's not sorted. It's no clear winner yet. So it's very hard to make those choices of build versus buy. So if you think about it from that perspective, you don't know what you're getting into is the right platform to get into. And so there is that hesitation because there are no clear winners either. What if tomorrow you get logged into a thing which is not the most optimal thing? So I think it has to be looked at both perspectives, but one needs to somehow find that balance.
But here, this is a good segue because, let's say you're looking to build an image classification model or something. That's a pretty, now a mature application of AI, and you're not going to sit there and try to invent your own image classification approach. It's better there to use some well-established stuff. If you're going to be doing graph stuff, maybe, that's a different question. So, and this is my segue here because there is a question from the audience. They're asking, NLP and images have been sort of at the forefront of what we consider super advanced AI, being led by the big incumbent AI research places. What do you guys think are the next showcase applications of AI that will sort of capture the public interest? Is it self-driving? Is it playing video games? Is it something else? I think NLP and images were given because they're so visceral, right? It's easy to conceptualize it. But so what comes next after that?
Well, I think NLP, the new next thing that happened was foundational models, right? So these massively large parameter language models like GPT-3, Facebook just released something yesterday. You're going to see that same kind of concept.
What are foundational models for people that don't know?
So foundational models are, GPT-3 was built by a company called OpenAI, and they trained this language model on the whole of the internet. And so they ingested all this data and they taught it languages, and you can go in and you can, it's got a cute little, the API test, you can do a cute little autocomplete on it, but it leads to things like, there's applications out there on the web that you can write papers. You put topics in, it'll write a whole paper for you. There's applications for it into, my background, which is genetics. You can actually predict protein sequences using these GPT-3 models or these foundational models, and they act as a base. And they're trained on the whole internet, and then you take smaller data and train it for your use case. You're going to see same thing happen with images. You're going to see at IBM Research, we're working on a whole slew of foundational models such that our customers can now train on smaller data, accelerates, and that's actually, while these models are very computationally intense and they use a lot of, they produce a lot of carbon essentially, they're not very green. If you look at the total cost across, once companies start using that, you're going to see it's actually good for the environment because you'll see a reduction in the cost that individual enterprises are spending to train these models. And companies like IBM and Google and Microsoft and Amazon, will get better at green compute, but you only need a small number of companies getting better at green compute to build foundational models instead of everyone needing to get really good at it.
Right.
To add to that, it's hard for me to imagine new areas of AI because it have to be from this world we live in. So language is important, vision is important. These are human perception systems. And intelligence sort of critically depends on perceptions like these. So these are fundamental in my mind, right? But there's I think the way to think about that, another way to think about that could be is how efficient are these kinds of perception systems, right? So today, for example, for a human being, it doesn't take that many examples to learn an idea, right? But our algorithms are not that efficient. We don't have we don't have ways to do efficient learning very, very easily. Things like self-supervision, like use or weak supervision, like learn from the limited examples you have and learn efficiently. So I feel like while the topics when it comes to languages and images, these are very fundamental. Maybe there would be an ad. There might be, multimodality. There might be, like DALL-E came about, and you say you give a text and it draws a picture for you. You say, I want a medieval picture of, people having wireless problems, and then it draws a painting with some monks kneeling down and praying to the wireless god. It's crazy the kind of context it has to be able to build something like that. So those things will obviously be there. So I think multimodal is here, and there will be many interesting things. But I feel a lot of effort and interesting things will happen in efficiency of learning and supervision and data and so on.
And,
what do you mean?
I think on top of that too, things, the reasoning, right? Kind of representing humans, so reasoning. So neurosymbolic AI, so neurosymbolic AI, which is kind of mimicking human reasoning, logical neural nets. So in and of itself, and so that's kind of reason-based AI. That's been around actually for a while, but the intersection of reason-based AI and data-driven AI has not happened.
Right.
And again, companies like IBM Research, Microsoft Research, Google Research are at MIT are at the forefront of how do we use reasoning-based AI to help inform data-based AI, such that you can do things like
hybrid
produce
AI
models
approaches,
better, hybrid AI, which then leads into things like 10 years down the road, like quantum AI. How is AI going to impact or quantum going to impact AI?
Right.
So it's kind of kind of reinforces what you said, and then of course, loosely self-supervised AI is really important as well.
Approach learning from multiple concepts or constructs, right? Paradigms. I mean, if a model has a context, an internal representation of something, which is what symbolic AI allows it to do, combine that with actual observational examples or examples and learn in a hybrid environment. These are important trends, and I see a lot of papers coming out in that as well.
A lot of papers, and a good way to conceptualize, if you really can't conceptualize what neurosymbolic AI looks like, we have what is called symbolic AI today, which is rules, and we've all been using rules for years, right? And so think of rules that you make as a human when you're trying to conceptualize something, whether you realize it or not, right? When you're looking at something, your brain is enforcing rules on the environment. It forces contextual rules, which is why sometimes you'll see someone out of context, like in a different place, and you won't recognize them. That's because it violates the rules your brain has put around understanding and representing that person. And so neurosymbolic is kind of taking what we think about as symbolic AI, which is rules, and applying more AI to it and letting it build those rules, if you will, on its own.
Okay. So more self-learning rather than us
and
steering
more
the
efficient
AI.
learning, a more hybrid learning. So learning, I think, is a very key operating term in my mind. Like, how do you learn? Can you bring various ways to learn better, learn more efficient, and so on?
That I have felt is, when we're talking about AI literacy and that kind of thing, a lot of times there is a focus on, people need to learn statistics, or they need to learn the particulars of some machine learning approach, what's supervised versus unsupervised. But I really think that a lot of people would benefit from understanding what is learning as a process and that kind of thing, in order to abstract and say, well, this seems like a learnable thing given the right circumstances, and we might be able to solve with AI, this business process, and then they can ask an expert to help implement it. But without having that abstract understanding of learning and how it relates to data or the real world, if you will, I think that is stopping people from being really creative in applying their business problems to AI systems.
Yeah, I mean, I said in my talk yesterday, right? Part of my talk is that part of the problem with the lack of adoption, or I guess getting the most value, we're getting to see good adoption, but companies getting the most value out of AI is, unfortunately, a lot of their leaders lack the vision to even think about how could I use AI maximally and how could I get the most value from it. So I think you're right. I think it is conceptually understanding how do I get value from it, which is why I've developed methodologies based on my experience and how to extract, use experts in AI to work with business leaders to extract what are the outcomes that a company has that we should be applying AI to, and then what's the value that has to the company? Because you can build the best AI model in the world. If it's not deployed, if it doesn't generate model, who cares, right? And by value, it's money. How much money am I making? How much money am I saving? I've heard teams say, well, I've got 1,000 AI models, machine learning models. I don't care how many models you have. I don't care how many API calls you have. What I care about is, are you making money for the company, or are you saving money for the company? Or are you making my customers' lives better and my employees' lives better? If you're not, I don't really care.
Yeah.
I have a segue here that I want to go to some of the questions that we've gotten in, and I'm going to do it this way. One direction that I think deep learning models are going to go in is geometric deep learning. I said it a couple of years ago that graphs are where it's at, and now we're seeing at NeurIPS and other places that geometric stuff is just super cool applications in science, applications in modeling business processes. I do think that with a bit of sort of literacy, sort of at the same level as most people have in terms of their understanding of the internet. You know, most people don't understand how routing protocols work, but they still understand communication, asynchronous communication, that kind of thing. You can understand your business in terms of a quantifiable process. First, this person has to make a decision, then depending on what that decision ends up with, we have these two options and it's a graph, and then you can automate it using AI. I don't know if people think about that today as a geometric problem, but have you guys come across geometric deep learning or graph deep learning and that kind of stuff in any circumstances?
Personally, I haven't, so I know it's a new topic. I mean, we've definitely used knowledge graphs, but not in a machine learning context.
Well,
so
tell me about that, because knowledge graphs are still, that's people that are leaning into stuff, and I think that's the future, and you obviously want AI there to make smart, insights.
Yeah. So the context we've used knowledge graphs is to really just represent knowledge in an efficient manner, right? So if you're parsing a bunch of documents and you want to make sure that we have a good way to represent that information, if you have a taxonomy or an ontology that sort of ties it together. So let's say if I understand the business logic of an organization, and I use that logic to build a hierarchy or a tree, and I represent information in that tree in a certain manner, then I can traverse the tree very efficiently to get to what I want to get. So that's how we tend to use knowledge graphs a lot.
It sounds abstract. I mean, how would you use knowledge?
So here's a way we use it in our software, right? So if you look at a data catalog, and I want to access data across a data fabric in a data catalog, you need a knowledge graph because you need to put context around the data that's spread across your environment so that it can be represented in a way that humans can understand. I think another place that I've personally used graphs is, there's lots of data that we put in relational databases that's actually graph-based data. And here's how you know it is. If you're trying to run a query and your query takes, more than, I'd say, a couple hours, you're probably trying to solve a graph problem, and it would be better.
That's because the joins are like so tremendously complex.
Yeah, the joins are tremendously complex. And here's an example. So when I was at Monsanto, we had pedigrees. So we have pedigrees of plants going back 50 years, and we have genetics data that's combined with it. We would run queries trying to go, 8 generations down. We'd go to lunch, we'd come back, we'd go to dinner, we'd come back, they'd still be running. So we converted that into a graph, and you're talking, using Neo4j, and that literally you're talking from, we didn't even give it enough time to complete because we got tired of it, to minutes, because it's not a relational problem. Yes, it's relational data, but the problem you're trying to solve of all these complex structures that intertwine with each other, it's really a graph problem. And I ran into this 25 years ago during my dissertation because I was working with populations of people that historically, they're called consanguous, which means they're cousins marry cousins, uncles marry nieces, things like that. So you get these incredible loops, right? Relational databases and relational math can't handle that. They get in terms of infinite new loops. And you need to use some level of graph to break those loops. Yeah. Well,
we were talking before about squeezing a problem from one type of algorithm into one that is not really meant for. Like in graphs, I've always found it, in relational databases, I've always found it very annoying to do things that are sequential, like moving time windows and that kind of stuff, because you always have to express everything as a lambda function. It's the fact that everybody uses SQL for everything can be a hindrance in a lot of cases.
It is. The world is definitely not relational. It's complex, and the interactions are so many. It's not just one-to-one. There's sometimes many-to-one, one-to-many, and they just you're right. I mean, we've been in sort of similar situations where we've really hit these join problems, and just a bad representation of knowledge at that point. It's just not the right way to represent it.
Do you guys think that knowledge graphs are also, because now you're talking about it as a way to, maybe information retrieval, that kind of thing. I do imagine that there is operational applications for it, that the company might represent their operational state as a graph and do, fraud detection is the obvious one, but you could do any kind of operational decision making based on those graphs.
Yeah, I mean, so fraud detection does use graph data. I don't know of any that uses any kind of graph-based algorithm, but it does use, knowledge graph type concepts to get those insights. What I was talking about was, we were representing the entire research and development pipeline using a graph.
Yeah.
I think there's absolutely applications for graph, but again, use the right tool, right? There's tons of relational data out there. And we used to think of relational data as, that's the simplest form of storage. Actually, the simplest form of storage is an object store. And so, start there and then find use cases where you need to, everything, where you store your data should be use case based in my mind.
Right. All right, and so this is the segue. So we've talked about graph, and then the next thing is, we were touching before on foundational models. I think most companies now don't have the resources to train these things from scratch. Meta just released the open source version of theirs, so anybody that's out there training a foundational model based on GPT-3, it's time to move on to the next ones. That's last year's stuff. But the question is, will companies, let's see, because there's a good question here. Let's see. All right. In the future, will all data science be outsourced to specialist companies? So the question is, yeah, maybe all companies don't have the compute resources to do that stuff, but there's certainly a scarcity of data scientists, and there's even more of a scarcity of sort of, I would say, AI strategists, people that can really put this stuff into action. Is it reasonable that the companies will be able to do this kind of complex stuff all in-house with the model complexity increasing and the data complexity increasing? Or so do you think that these capabilities will continue to evolve in-house in all the companies, or will we see specialist companies, big companies like Google and those building the foundational models, and then specialist companies implementing them in?
It's hard to say. Again, it's a really difficult question. I have no idea of how it'll all play out, but I do sort of draw an analogy between how software is being done today, and it shouldn't be very different. I mean, it could be very different, but I mean, it's hard to make those sort of jumps. There are going to be few companies which will really be really good at building these very huge, parameter space models, and not everybody can do that. It'll require space, the kinds of complexity costs that not everybody can do that. And again, in the best interest of citizenship and democratizing AI, and these companies will make them public and people will use them, in my mind. And some companies might even build a whole bunch of software wrappers around it to really make it easy to use, easy to deploy, easy to do things. So there might be things like that might play out. But then there would be a whole bunch of space where, there would be room for us to innovate and play and build our own custom spaces and so forth. So I sort of look at the world in that manner. Complexity is definitely something that you would want to try and take away, but then you don't want to do it at the expense of all kinds of things either.
Let me refine the question here, because we have spoken about organizational changes where instead of having these ivory towers as scientists, you have them distributed in the organizations and that kind of stuff. Is it still in-house, all of that kind of specialization, or will we see more niche companies having to be part of the organizations in order to put these things and affect change?
Yeah, so I think the ultimate ideal state for any company is a hub and spoke model for data science teams. You need a core centralized team to do kind of cross-cutting company things as well as drive innovation. They should, their projects should fail a lot more than those that are in the business where they're actually responsible for supporting a direct P&L.
Yeah.
And as soon as you pull someone out of a line of business, 2 days later they have no idea what's going on. They don't know what the priorities are anymore, they don't know, so you need that federated model. I think your question about is all this going to be outsourced, that comment kind of says no, right? But however, I think this concept of foundational models and transformer models enable companies to keep, and data scientists in companies, to keep getting more and more value from these base models and allowing their companies to train on things that are specific to their industry, to their company, to their use case. And so I think, he said, there's going to be some things that are commoditized. We saw that already, right?
Yeah.
Everyone used to build their own marketing models. Everyone used to build their own kind of NPS models. Those are commodity. Like I said earlier, if it's commodity, buy it, right? But if it's not commodity, your team can then focus on the things that are going to differentiate, and absolutely you should use these technologies that IBM research, that Microsoft, that Google, that Facebook, or Meta, I guess, are all building to accelerate your teams. And ESG is really important. It helps to reduce the footprint of AI, and it helps to really, if you look at the total impact of a company from an environmental standpoint, you have to go all the way back to your data. And so you have to look at how can I build and run and deploy these models in the most efficient manner. Leveraging foundational models and transformer models instead of starting from scratch is a must-do.
That's something we keep circling back on here, where if you're going to build something from scratch, make sure you're spending and putting that effort into stuff that isn't already well established, and you're not reinventing the wheel for no reason.
And for a lot of companies, in like the kinds of companies we are working with, engineering is where they want to put effort in, not in model building, because they're just very niche, very specialized kind of work, right? But the engineering around it's really important, right? So companies are spending a lot of effort there, spending a lot of their money there, and then hoping that the modeling piece comes for free, or comes from the open source world, or comes from specialized organizations.
Let me get your take on this, because for a couple of years here, the idea, there were two ideas that I felt were a little bit fun to say, but I don't know if they really reflected the true challenge of machine learning. They would say, what data scientists do is hyperparameter tuning, and then most of our time is spent on data cleaning. I don't know if that means like getting rid of missing values or whatnot, but in my experience, the complexity of the problem lies in modeling the problem as an AI or as an engineering challenge. And once you've figured out, what do we need to take into account? How are we going to structure this? How do we measure the success or not? That's all soft stuff that starts even before any engineering starts at all. And then the engineering stuff, in general, is quite easy because you've scoped it. You know whether it's doable or not, and that kind of thing. Absolutely.
I mean, framing the problem is one of the first key stumbling blocks, and not framing properly is the first stumbling block, right? There's just so many things that are going on. I mean, not just framing the problem, but framing it as a user problem. And that's like the shift from, impersonal AI to human-centric AI. I mean, that's a shift there, right? And so I think that's something important. Automation versus augmentation. I mean, that's a spectrum.
What does that mean?
So how much are you going to, people start from a default place of automation. Like, it just, automate the heck out of anything, really, right? I mean, and that includes people. It's just like a default mindset we have, but we should think of it as a more grayish problem, right? I mean, some parts people don't want to get automated. It's actually inefficient to automate, and it takes away from our life at some level, right? Augmentation versus automation, and there's a whole spectrum there. What does that look like? The third is like, what kinds of things are you optimizing for? Are you optimizing for the right reward functions, or are you optimizing for something really foolish? I mean, God knows. So I think those are really soft problems, like you say. They're sort of like even before you've gotten into any of this. But are you thinking about it?
But it's non-trivial stuff. I mean, I don't think a lot of people understand, for example, when you're talking about objective functions, that some can be orthogonal to each other. You want to both save the environment and deliver the package as fast as possible.
And so, I mean, I think I've been talking for the last 2 years about this concept of human-centered AI, and I'll extend what you said even further, right? I can think of very few cases where companies have started with the human and said, how is this AI going to make the end users, the ultimate person being impacted, how's it going to make their life better, cheaper, or faster? How's it going to be making the person that's using the model's life better, cheaper, or faster? Those two people, those two humans, may or may not be the same person. And then why is that model being built in the first place? How is it going to be used? And then what problems is it trying to solve in the first place? And then tying that to a business strategy. You need to start with the human to frame the problem, because that enables you to think about other things that we didn't talk about, which is fairness and explainability and robustness. If you don't know who the human is, you don't know what the protected classes are, so who can be discriminated against, because you can't eliminate every bias. It's a trade-off, and tuning for bias, adjusting for bias versus adjusting for the models. Usually they're counter to each other. And so you need to understand who the human is. You need to understand what kind of data is going to be going through that in order to know what kind of privacy protection I need. How well do I need to protect this endpoint against bad actors who may be trying to extract information from the model or poison the model. And so all of these things, start with the human, and very often we start with the technical problem.
Right.
And what really should happen is the ethics of the organization and the human problem you're trying to solve should be represented in the technical implementation. What we're doing now is we're building a technical implementation and saying the human, this is how the human's going to use it. That's completely backwards and asinine in my mind.
Definitely backwards. It's technology first, human second, which is just not the way to think of it.
Yeah, and then you start thinking about what business problem does it solve, which gets back to money, right? Because we're all in the business to make money. And then you start thinking about things like how am I going to put this into production, right? So then you start thinking about the more engineering problems. And so, if data scientists are spending 80% of their time getting and cleaning the data, they're spending their time on the wrong things.
Yeah. Well, that is a great segue to how humans will be affected by AI. And I think a lot of people are wondering, will the expensive jobs disappear first? Will the less expensive jobs disappear first? You were talking about automation. Should we automate everything just for the sake of it? You have on the one hand, a lawyer that is spending 80% of their time looking through old documents to try and find precedent and quotes. And on the other hand, you have somebody that maybe is doing manual labor, and you're thinking, oh, maybe I can do a robot to do that stuff.
Yeah.
Where do you think it's headed?
I mean, my personal opinion is, and IBM's stance is, if it affects a human's health, wealth, or livelihood, absolutely 100% has to be a human involved in the decision. So, no, it should be totally augmented. Everything else, I think, you said this earlier, it depends on the use case. I mean, I've been automating processes, whether AI-driven or physical processes, my whole life, or my whole career, adult life, I guess. If you automate a process that you don't understand, you're not creating value.
Right.
Right. And so how do you automate? You have to manually build and execute the process for a while, using Six Sigma and Lean principles to optimize it. And then you represent that in your background, which is how do I mathematically represent this process? And then you can automate it. People often skip the mathematical representation or mathematical optimization of the process, and they just apply AI to specific outcomes. If you apply AI to specific outcomes and have a mathematical or kind of operations research representation of that, you're going to get literally orders of magnitude more value out of it, because this model is going to predict here's how it's going to affect my supply chain, here's all the other decisions I can make, here's all the other processes that downstream that can now be optimized. And so you literally get orders of magnitude more value out of if you combine machine learning and operations research or decision optimization.
Well, operations research is still a super niche area. When we use the word optimization, it's a very specific meaning that we think of when we say optimization. And talking to organizations, you will have like logistics companies and others that have OR people employed, but in general, because obviously OR has applications everywhere, anywhere where there's a process you can optimize. It's not that well understood by businesses what optimization is and what you can potentially do with it. I mean, you only have that as like a colloquial term, not as a mathematical term.
Yeah, so let me give you a good example that everyone can understand. The most complex optimization research problem that exists in the world is sports team planning, right? Maybe I'm overstating it a little bit, but right, it's something that everyone can understand. So for instance, the NFL, the National Football League in the US, has millions of constraints that they put on it. I'm not exaggerating. Millions, because of how people get paid, what the things are. We can't do that using optimization today, but that is an optimization. Scheduling for FIFA, optimization problem. How do I maximize the value for the viewers? How do I maximize the value for the people who are paying to broadcast it? How do I maximize the value for the people that own the teams?
Yeah.
If you ever hear, I want to maximize this value, that's an optimization, that's an OR problem.
We're not using AI to solve optimization problems. Is that something you think?
We're definitely using heuristics and smart algorithms to do that.
Yeah.
So we use a lot of those kinds of simulated and annealing, ant colony, and those kinds of things. But multi-objective optimization is definitely an area. But it's hard to, when you're solving a problem, it's hard to keep it only to intelligence. Intelligence does involve some amount of optimal decision making at some level, right? So it's there. I mean, even when you're solving AI problems, there's some optimization that's happening there, right? The gradients are being captured in some manner, right? There's, and so, I mean, it's not segregated. So I would say, yeah, it's there. Optimization is always there along with, some kind of whatever learning that's going on.
Yeah.
But yeah, how much of it is explicit versus how much of it is not explicit is a question.
Right.
But we definitely do a lot of optimization everywhere. So
Yeah, I would like to see sort of some cross-pollination between traditional, combinatorial optimization experts and modern deep learning as we're seeing it, and using those learnings from both fields and combining them.
Yeah. I think you see that in some industries. So agriculture, where I came from, you see that. Oil and gas, you see that.
Yeah.
Industries that have been using optimization for decades, you're seeing that cross-pollination as they're bringing in these new fields, or these new concepts. So, oil and gas companies, it costs them $1 billion to drop a well.
Yeah.
So they use a lot of AI, a lot of deep learning, and a lot of optimization to figure out how do I drop the well in the exact right spot, and then how do I optimize the output of that? So that's an area where you've seen this for years. I think in nuclear you see kind of the same thing. So energy production, there's a lot of optimization and has been for decades.
Yeah, yeah.
And then obviously, insurance uses a significant amount of optimization.
Yeah.
So you've seen where you've had these skills for a long time, because you think data scientists are hard to find, right? You need a real pure mathematician who's trained in optimization research to do it. Luckily, there's lots of tools. There's Python packages out there that you can use. There's there's tools you can buy off the shelf. But it's
the hype today is AI, but I mean these things have always
I
been
lump that
around.
into AI.
Yeah.
Yeah.
But yeah, these are tools that people should be familiar with. We have so many people in our organizations invested in these topics.
Yeah.
While AI is very important and all that, there's so much work happening in Bayesian modeling. There's so much work happening in optimization.
Yeah.
It sort of does not get the same coverage, but it's all there and it's very important.
When I talk about AI, I kind of lump all. Actually, it's rules, it's statistics, it's machine learning, it's deep learning, it's because senior executives for the most part don't understand the nuances of even some data scientists would lump Bayesian into AI, right?
Everything is just AI.
Everything is just AI, right? So it's our fault as companies who drive marketing, right? But Bayesian is a huge, especially the challenge with Bayesian before was you couldn't compute it, right? So now you can compute however many priors you want. It's just about how much money you want to spend.
Yeah. But I do think it's a good catch-all term for state-of-the-art decision making. I mean, it was fair to call IBM Deep Blue AI back then. I think today we have systems that have superseded it, and so you wouldn't, if you say AI, that shouldn't be like the first thing you think about.
No,
it
should be Jeopardy, it should be Google's Go, it should be IBM's Project Debater. There's lots of things that humans can get their head around, that relate to them. It should be, Siri, your location tracking, whether you like it or not, how companies use your data to sell you things you don't want or need. And so, we interact with AI every day.
It's a catch-all term. It simplifies it. It lets people know what the general area is that we're talking about.
I used to think it was a little bit cringy, but it's useful. It's a short word, and I don't actually feel like saying, it's this kind of specific machine learning. It's AI.
Well, people wouldn't know what you're talking about anyway. So.
Yeah. Okay, but I'm asking everybody the same question here, and the question I keep asking is it better? You have to pick a side. Move fast or move efficiently? Which one do you pick?
Fast.
Fast.
Efficiently.
Efficiently. Okay, give me your reasons. Why fast and why efficiently?
Fast is important because as you move fast, you can learn.
Okay.
And people in this field, in my experience, tend to, if you focus on efficiency, they'll get into paralysis analysis. Analysis paralysis.
Yeah.
And so always encourage team to move fast, including cutting bait fast.
Right.
When you realize it's not working, stop, go back and do it again. But efficiency is important.
What about efficiency?
So I would say, since you posed it as a one versus
it is. You got to pick the other side. Tell me.
Yeah, but efficiency because for very simple reasons. I mean, it's very easy to move fast because you tend to spread yourself out too thin, and it just sort of loses focus and that kind of thing. If you're going to do one thing, do it well. Look at a company like UPS. I mean, UPS saves about $500 million a year with just one app, the driver navigation app. That's what allows UPS to be such an efficient delivery system. They don't have AI across the organization. They're not implementing AI in like, customer support and supply chain, but they're just doing one thing. They're doing it really well.
It's a pretty core thing.
It's a pretty core thing, and it's just one thing. So when you try and do, and this I'm thinking of from an AI perspective. When organizations are bringing AI to every place, it confuses me. It's like, can you really try and do everything all at once? I mean, can you just find out what's the most valuable thing? Focus on that. Try and bring the maximum value. And then
I think some people, if they play the devil's advocate here, the thing is, I agree with you. You see delivery companies working with language models so that they can do chatbots and stuff like that. But the thing is, obviously, the most value is if you apply it to a core business process. That is where you make your money, and if you make that better, it would be better for you. But maybe there are some thresholds to you don't want to rub the circles, or things are working, don't touch it, kind of thing.
In my mind, when I say move fast, I don't say move fast doing everything. I say move fast strategically, right? You can still move fast, but it's also stopping fast.
Right.
Stopping fast is, if you were to ask me, what's the most important thing for a data science leader to do? It's shut off projects when they're not working, shut off experiments.
Let's cut it here in the middle and say that work on the right thing is important.
Absolutely.
So you didn't give us the choice of the middle.
All right. This conversation went much faster than I would have wished. We could have probably chatted about this for quite a while. I love optimization. I think we got to talk about some important things, the models that everybody are thinking about now. And so hopefully you enjoyed it. We're going to be right back with some more sessions here. Stay tuned, fill up your popcorn, and I'll see you in just a bit. Ciao.
Thank you.